Good day. Let's talk about organic and inorganic matter around us. Everything living and non-living in the world is constructed from chemical elements. Find and click on the hair. This is a representative of living nature, and only in living nature are all elements characterized by the complexity of chemical compounds. This is predetermined to their certain orderliness at the molecular level. The difference between the chemical composition of the organic and inorganic world and detection already at the molecular level. Exists even a special science of biochemistry. The chemical elements of living organisms. Click on the periodic table and consider them. The composition of vegetative and animal cells includes more than 70 chemical elements. But there are no elements of something in the cell that are characteristic only of living nature. These same elements are also found in non-living nature. All chemical elements are divided into 3 groups according to their content in a living cell: macroelements, microelements, and ultra-microelements. The elements oxygen, C, carbon, H, hydrogen, N, nitrogen are sometimes considered a separate group of organogenic elements due to the fact that they are part of all organic substances and make up to 98% of the mass of a living cell. When you studied chemistry, you learned about groups of substances such as acids, salts, oxides, etc. All of them are common in inanimate nature, outside living organisms. Therefore, they are called inorganic substances. However, this does not mean that there are no inorganic substances in living organisms. There are, and they play a very important role in the process of vital activity. Inorganic substances usually enter living organisms from the external environment, with food in animals or with a water solution through the surface of the organism in plants, fungi, and bacteria. But in some cases, living organisms can synthesize them on their own. So, stomach cells of vertebrates synthesize hydrochloric acid. Functions of inorganic substances are quite varied. Let's find out the functions of inorganic substances in the cell. Select a flask. Cations and anions of soluble salts create a potential difference between the contents of the cell and the surrounding environment, ensuring the conduction of a nerve impulse. Hydrogen cations, H+, provide acid-alkaline balance, maintain stability of intracellular environment. Hydrogen cations, H+, provide acid-alkaline balance, maintain stability of intracellular environment. Pick a bone. Salts that dissolve poorly, such as calcium and phosphorus, form support structures, for example, in the bones of vertebrates. Ions of metal elements are components of many hormones, enzymes, and vitamins, or participate in their activation. Click on the package with the medicine, the capsule. Inorganic compounds can be present in living organisms, both in soluble form, in the form of ions, and insoluble form. Many salts are represented in dissolved forms, Na+, K+, sodium ions, potassium ions, and others accumulate on different sides of the cell membranes and provide a different charge on their surface, which enables the conduction of nerve impulses along the nerves. There are many more organic substances in the world than inorganic ones. Now, there are already more than 25 million of them, and new ones are constantly being opened or created. You already know that all organic substances can be divided into 4 main groups: proteins, carbohydrates, lipids, and nucleic acids. All these substances we consume in food every day. Click on the chalice. The composition of all these substances necessarily includes atoms of carbon, C, hydrogen, H, and oxygen, O. Organic substances can also contain nitrogen, N atoms, mandatory components of proteins and nucleic acids, phosphorus, P, components of nucleic acids, sulfur, S, present in proteins but missing in nucleic acids. Organic molecules are divided into two groups by their size: small and large molecules, macromolecules. Macromolecules have a mass of over 1,000 atomic mass units. They consist of identical small organic molecules called monomers. Another widely used name for such molecules is polymers. A striking example is a protein. It is a polymer consisting of monomers, amino acids. A striking example is a piece of meat. For example, a chicken leg. In addition to their large mass, macromolecules also have at least 30 carbon atoms in one molecule. The production of polymers by living organisms is called biopolymers. For example, capron, which is produced artificially, is a polymer, and silk, which is produced by insects, is a biopolymer. They both consist of small organic molecules, monomers. The most common biopolymers on our planet are the carbohydrates of cellulose, produced by plants, and chitin, produced by fungi and insects. Biopolymers also include enzymes, pepsin, transport proteins, hemoglobin, standby substances of living organisms, starch, glycogen, and so on. Due to their structure, some biopolymers have amazing properties. One of these polymers is a spider's web. It is produced by representatives of the arachnids. Considering its composition, the web belongs to proteins. But the web is not an integral thread. It has a structure like that of a hawser, woven from many microfibers.